Hi everybody, thanks for checking into another math video. Hope you're doing well. In this video we're going to figure out how we can calculate an arc length, that is the length of an arc, and the area of a sector. Alright, sector area and arc length. Let's get started first on arc length. Alright, so an arc, if you're not sure what that word means, it's a portion of the circle. You know, maybe it looks like that, just marked off. We use the letter S to represent an arc's length, and its length is a function of the radius of the circle, all right, and the angle in between those two radii right there. All right, so that's called a central angle. We'll use the letter theta, the Greek letter theta, to represent that. And so here is the formula for calculating the length of an arc. It's theta divided by 360 times 2 pi r. All right, so that's the formula. Let's have a look, dig into that formula a little bit so it makes a little bit more sense to us. All right, so the formula there, theta over 360 times 2 pi r, is the formula for calculating the length of an arc. And since an arc is a fraction of the circle's circumference, all right, this is what we're going to use here. The arc is a fraction of the circle's circumference. That circumference is 2 pi r, right? Hopefully you remember that from some other math experience you may have had. 2 pi r is the circumference of a circle. And the fraction that the arc represents is that same fraction, theta over 360, all right? So that's the fraction that we're going to use in calculating the arc length. Since an arc is a fraction of a circle, what fraction is it? It's theta over 360. That's the fraction. And all you have to do is to multiply that fraction times the circumference to find the length of the arc. All right, so let's try that once. It's pretty simple, I think you'll agree. There's a circle. I've got a 10 centimeter radius on that circle. I've got a 150 degree central angle, and we are going to find the length of arc AB. Incidentally, that little curve over the letters AB, that's the symbol that we use to represent arc AB. So you might see that from time to time in your math books. All right. So find the length of arc arc AB, and there's our formula. Theta over 360 times 2 pi r equals S, and I've never really understood why we use the letter S for arc length, but be that as it may, let's figure out the circumference of the whole circle first. 2 pi r, if radius is 10, gives us 20 pi centimeters for the entire circumference of this circle. And what we're going to do is multiply that circumference times that fraction, theta over 360. All right, so 150 over 360 kind of reduces down to 5 over 12. So let's multiply 5 over 12 times 20 pi. We get 100 pi over 12, which reduces down to 25 pi over 3 centimeters. That is our exact representation of arc AB. Sometimes we're going to use that length in other calculations, so you want to be able to use the exact representation of that arc length in those cases. But other times you just want to know what the arc length is, and that's the only question, and it's fine to use an approximate answer in most cases. All right, so I'm showing you here the exact representation and the approximate representation. Once again, this is part of our understanding of numbers and how to represent quantities in different ways, and so it's part of your learning to be able to represent both the exact and the approximate length of an arc, something like that. All right, that'll come up again, I'm sure. Let's talk about an area now of a sector. All right, a sector is that pizza slice kind of shape. It's defined actually as the closed area between two radii and an arc. So now we know what an arc is. So, and I'm sure you know what a radius is. So the area between two radii and an arc is called a sector, all right? And its area, to calculate, this is going to sound kind of familiar, I hope, but the area of a sector is a function of the circle's radius and, once again, that central angle, all right? So in the same way that an arc was a portion of a circle, a sector is a portion of the circle's area. Okay, and so here's the formula right there. Once again, you see theta over 360, but now we're multiplying that times pi r squared. Pi r squared, what is that? Well, I think you know what that is. That's the area of a circle. All right, but let's just dig in one more time to the formula here. And yes, pi r squared, that's the area of a whole circle. So we're going to take that fraction once again, theta over 360, and multiply it times the area of the whole circle. A sector's area is a fraction of the total area of the circle, which is pi r squared, and all we have to do is multiply that fraction times the total area to find the area of the sector. All right, pretty straightforward idea. Let's try it once just to kind of finish up this video here. Let's say we've got a sector in a circle. The central angle is 117 degrees and the radius is 16 inches. And so there's our formula, theta over 360 times pi r squared. And we're going to figure out theta over 360 first. That happens to be exactly 0.325. And then the area of the circle, 16 squared is 256, so that's 256 pi is the area of the whole circle. We multiply those two numbers together. Easy, right? And you get 83.2 pi square inches. That's the exact representation. If it's okay to use an approximate solution, that works out to 261.4 square inches. Please remember to put your units in there. And that's all there is to it. Really, it's a pretty straightforward idea. Just kind of pay attention to what your situation demands, whether it demands an exact representation of these measurements, or if an approximate representation is good enough. All right. Hey, thanks for watching. Hopefully this was helpful. Now let's get busy and do some more math. All right. Bye.